So I wouldn't read over the whole background information. So what we have is that this is a normal distribution, have a mean 1.25, and the standard deviation is 0.46. In other words, we have x follows a normal distribution, and the mu is 1.25, and the variance would be 0.46 square. So we have mu is equal to 1.25, and the sigma is equal to 0.46. So the reason why we have square here because we need a variance instead of standard deviation. And we want to find the probability that x is between 1 and 1.75. So once again, we cannot find the probability from a regular normal distribution because we are not able to integrate the whole PDF thing as what we showed over here. I just want to mention this again. The reason why we have to go over the standard normal distribution is because we are not able to integrate this thing. We are not able to integrate this thing over here. Okay, that's why I need to do the standardization. Okay, so if we want to do the standardization, so we know that the formula z is equal to x minus mu is divided by sigma, and we have two x values. We have x1 is equal to 1, x2 is equal to 1.75, and then we just need to find that the corresponding z value z1 is going to be equal to x1 minus mu over sigma, which is 1 minus mu 1.25 over 0.46, and this is equal to approximately negative 0.54. Okay, and z2 would be equal to x2 minus mu over sigma. X2 is 1.75 minus 1.25 over 0.46, which is approximately equal to 1.09. Okay, and then of course the probability that x is greater than or equal to 1, less than or equal to 1.75 would be equal to the probability that z is greater than or equal to negative 0.54, less than or equal to 1.09. Right? Because we have done the standardization over here already, and this would be equal to phi 1.09 minus phi negative 0.54. Which means this is equal to the area to the left of 1.09 in the z table and the area to the left of negative 0.54 in the z table. Now let's take a look at how to find those two numbers. First of all, let's take a look at how to find this. So we go back to the z table. Z table is over here. So first of all, we want to find the average to the left of 1.09, right? 1.09. So let's I don't want that. 1.09. We go to 1.0, and then 0.09 is over here, right? So the area to the left of 1.09 is 0.8621. So once again, the area to the left of z is equal to 1.09 is 0.8621. And then we want to find the area to the left of negative 0.54. Negative 0.54, we go to here, negative 0.5, and the 4 is over here. Okay, this is column for 0.04, negative 0.05. So this would be 0.2946. So that means the area to the left, the area, excuse me, the area to the left of a negative 0.54 is 0.2946. All right, once we know those two numbers, we just need to bring it back to the problem we just talking about. So this would be equal to phi 1.09 is 0.8621 minus the phi negative 0.54 is 0.2946, and this would be equal to 0.5675. That's just how to find the probability of this interval. Okay, so once again, since we're not able to find the probability of this interval x is greater than or equal to 1, less than or equal to 1.75 directly, because we're not able to integrate the PDF of normal distribution, so we gotta standardize it. Okay, by applying the formula z is equal to x minus mu over sigma. Okay, once we got those two corresponding z values, we can convert the probability x is greater than or equal to 1, less than or equal to 1.75 into a completely equivalent form, which is the probability z is greater than or equal to negative 0.54, less than or equal to 1.09. And then we can find those two numbers from the z table. All right, so that's pretty much the same thing as what this is the solution part. First of all, of course, we want to standardize this random variable by x minus mu divided by sigma, and we have negative 0.54 and 1.09. So if we want to find the probability z is greater than or equal to negative 0.54 and less than or equal to 1.09, we have this is equal to phi of 1.09 minus the phi of negative 0.54. And we got those two numbers, and the subtraction is equal to 0.5675, which is exactly the same thing as what we get up here. Right? I wish this makes sense to you. So this is the graph. Okay, this is the graph. How we explain it in a graph. So since this is a regular normal curve, with mu as 1.25, we can tell the symmetry is 1.25, right? And then we want to convert it to a z curve, from a regular normative to a z curve by applying the formula once again. Z is equal to x minus mu over sigma. So the reason why I keep writing this thing down again and again is because this is super important to understand the standardization we're talking about here. All right, once this is clear, let's take a look how to find the probability that x is greater than 2. So same thing, right? Same thing. So we do the standardize by applying the formula z is equal to z is equal to x minus mu over sigma here. So what we're doing here, x is greater than 2, we subtract 1.25, which is mu, and then divided by the sigma 0.46 to accomplish the standardization. And this would be equal to z is greater than 1.63. So since as what I mentioned before, we are not finding this probability directly from z table, right? So what we can find is the probability that z is less than or equal to 1.63, which is a phi of 1.63, right? So this would be 1 minus phi of 1.63, and if we go back to the z table, we can tell that now this one, z table here, and we're looking for phi of 1.63, 1.63, 1.6, and 3 is over here. So the error to the left of 1.63 is 0.9370. And then we subtract that from 1 to get the probability that x is greater than 2, which is equivalent to the probability that z is greater than 1.63. this is 1 minus point what is that 9484, which is 0.0516. Okay, so that's pretty much how to find this, how to figure out this problem. All right, this is the most important thing, and the standardization, this thing here, is the most important thing in this section. Okay, and the reason why we need to do that is because that we are not able to integrate the regular PDF, the PDF of regular normal distribution. Okay,